Theorem 6.2. Let us first recall Theorem 6.1. Theorem 6.1 states that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in same ratio. So here we have a line DE, and DE is parallel to BC, and it divides AB and AC at two distinct points D and E. Then we have AD upon DB is equal to AE upon EC. The two sides are divided in same ratio. Now, in this statement of Theorem 6.1, this green part is the given part. It says that if a line is drawn parallel to one side of a triangle, that means it is given that the line drawn is parallel to one of the sides of the triangle and it intersects the other two sides in two distinct points. This is given. And this is what we concluded, that the other two sides are divided in the same ratio. Now, what could be the converse of this statement? Whenever we do a converse of any statement in mathematics, the conclusion of this statement becomes the given, and the given becomes the conclusion. And therefore, Theorem 6.2, in Theorem 6.2, we have if a line divides any two sides of a triangle in same ratio, that means this part came as given here, then the line is parallel to the third side. That becomes the conclusion. Now let us prove this. So Theorem 6.2 states that if a line divides any two sides of a triangle in the same ratio, this is given that the ratio is same, then the line is parallel to the third side. This is what we need to prove, okay? So given, in triangle ABC, as you can see here in this triangle, DE is a line such that, so DE is a line such that AD upon DB is equal to AE upon EC. Okay, so this ratio is equal and it's given to us. We need to prove that this line DE is parallel to BC. Okay, so we are going to use proof by contradiction method, and you know we start by assuming the opposite of what we need to prove. So let's assume the opposite of this. Let us assume that DE is not parallel to BC. So if DE is not parallel to BC, can we have another line which is parallel to BC? Then yes, we can. So if DE is not parallel to BC, draw a line DE dash. So let's draw a line DE dash which is parallel to BC. So this new line DE dash is parallel to BC here. Okay. Now, according to Theorem 6.1, can we use Theorem 6.1? Yes, we can. So according to Theorem 6.1, we have AD upon DB is equal to AE dash upon E dash C. Since this line is parallel to BC, we have AD upon DB is equal to AE dash upon E dash C. Using Theorem 6.1, if a line is drawn parallel to one side of the triangle, since this new line that we have drawn is parallel to BC, then the ratios are equal. But the ratio that is already given to us states that AD upon DB is equal to AE upon EC. It's already given to us in the question. It's given. So now we have two ratios which are equal to AD upon DB. And so since AD upon DB is equal to AE upon AE dash upon E dash C, and AD upon DB is also equal to AE upon EC, we conclude that these two ratios are also equal. These two ratios are also equal. Therefore, we can say that AE dash upon E dash C is equal to AE upon EC. Now adding 1 on both the sides, we get AE dash upon E dash C plus 1 is equal to AE upon EC plus 1. Now E dash C becomes the LCM of the left hand side and EC becomes the LCM of the right hand side, and so we get AE dash plus E dash C upon E dash C is equal to AE plus EC upon EC. And now if you look at AE dash plus E dash C, you will see that AE dash plus E dash C gives the whole line AC. Similarly, AE plus EC, so if you look at AE plus EC also gives you AC. And so we get AC upon E dash C is equal to AC upon EC. That means we get 1 upon E dash C is equal to 1 upon EC. And now if we take EC to that side and E dash C to this side, we will get 1 into EC is equal to 1 into E dash C, and that will give us EC is equal to E dash C. That means E and E dash coincide. Therefore, we can say that E and E dash coincide. That is, they are the same points. And you can see in the diagram that means DE and DE dash is actually the same line. Therefore, as we had already said that DE dash is parallel to BC, we can also say that DE is parallel to BC.